Statistics is basically an applied subject. The use of statistical tactics in different situations must be done very wisely with all care and precaution. For the same purpose, a fixed, uniform statistical technique may not always be appropriate. It may differ from situation to situation. In real life, we come across a variety of situations with which we have to deal and about which it is not possible to anticipate in advance. In such situations, it all depends upon the wisdom of the user of the technique, that how he or she makes modification in the existing technique for getting more valid and reliable results. This is why generally I used to say that it may be simple to learn the statistical techniques, but it may be difficult to apply them in real life situations. I would like to mention here two such cases in this regard. Suppose that we have to estimate the urban population of Bihar on the basis of a simple random sample of cities and towns without replacement. The usual formula in such a case, which is considered as optimal in many ways, is capital N into X bar, where capital N is the total number of cities and towns in Bihar, and X bar, of course a small x bar, is the sample average population in the sample of n randomly chosen cities and towns from Bihar. Now, suppose that Patna comes in the sample. We all are aware that there are large differences in the population of Patna and those of the rest of the cities and towns in the state of Bihar. The population of Patna is several times more than that of any other city or town in Bihar. Now the question is, do you still think that the estimate capital N into X bar is the best estimate of the total urban population of Bihar, especially when sample size small n is small. In such a case, I think it may be disastrous to use capital N into X bar as the estimate of the urban population of Bihar. Would there be any other reasonable estimate in such a situation? The answer is yes. Suppose X1 is the population of Patna, which has come in our sample. Then a more reasonable estimate of the total population of Bihar would be X1 plus capital N minus 1 by a small n minus 1 into X2 plus X3 plus X4 and so on up to Xn. That is sum of the rest of the cities and towns. Of course, the population of the cities and towns which have come in our sample. Here in this case, what we are doing? We are doing post-stratification after looking at a particular observed data. And in this way, we can modify our estimate. We can suggest a more reasonable estimate for the total urban population of Bihar. For the second example, suppose that we have to estimate the average yield of trees planted in a row. Suppose that for this we take a random sample of 5 trees. If Xi denotes the yield of the ith tree in the sample, then a good estimate, which is generally used in practice, is the sample mean X bar, which is in this case X1 plus X2 plus X3 plus X4 plus X5 divided by 5. This is what we generally calculate. But suppose after drawing the sample, we find that 2 of the trees chosen are next to each other, with corresponding yields, let us say X2 and X3. Then question is, does X bar, that is the usual sample mean, still remain the best estimate, or there is some scope of improvement in it? It is evident that if the 2 trees are next to each other, if they are consecutive, then their yields might be highly correlated. In such a case, it would be better to find first the average yield of these two consecutive trees. Let it be denoted by a small y. That is, a small y is equal to x2 plus x3 by 2. Average of the yields of the two consecutive trees. Then we may be better off in giving an alternative estimate as x curly equal to x1 plus y plus x4 plus x5 divided by 4. That is what we are doing here, that in place of x2 plus x3, we are writing y. We are taking the average of x2 and x3. We denote that by y. Now we are using only 4 observations, only 4 values for finding the mean. And that is x1 plus y plus x4 plus x5 by 4. It may be seen, or you may say it may be verified, that if the yields of the consecutive trees are highly correlated, then the variance of x curly is less than that of the usual estimate x bar. So, use of statistical techniques requires wisdom. It needs wisdom. Thank you. Thank you very much.